We now have Vivado and all the FPGA support files ready so we can get started writing code. But before we do any of that, I just want to walk you through all the steps to implement an end-to-end FPGA project from the beginning of creating a new project all the way to implementing it on the board. And we're going to start with something really simple. So we're going to start with implementing this here. And frankly speaking, most of the course we're going to be spending implementing something very similar. You might be looking here as like, is this right? Yes, it is right actually. So this is just a black box. I want you to think of any design that we're doing as a black box. And a black box usually have inputs and outputs. So I'm going to say like, okay, we have like an input in here and an output in here, and you can call it whatever you want. Let's assume that I'm going to call this is I, or just call it like for sake of simplicity, let's call it I, and this one here is O for input and output. And what we will be doing for now is we're going to be implementing this particular circuit. You might be looking like, what does this circuit do? Well, it's up to you. Whatever you want to put inside that box in here, we'll go through it. But now, because what we aim is not design a new circuit in this video, but I just want to show you how we actually go all the way from starting a project and implementing it on the FPGA board. I'm going to do something really simple and stupid, which is just, I'm just going to connect the input to the output. I'm going to connect this to a switch, and I'm going to connect this to an LED. And whatever we do on the switch will be reflected on the LED, and that's what we're doing. So the name of the signals we have are I and O, and that's pretty much it. It's really straightforward. It's really easy, and the reason why is I don't want you to take a look at FPGA or the Verilog code we're going to write for this particular module or circuit. So let's get started. So I'm going to go ahead and open Vivado in here. So we'll do that. I'll just keep that in here on the side so that you get to see it. So in here, what you will see is I'm basically starting a new Vivado project. So all you have to do is just do this, create a new project. So you do that. I usually store all my project in the same directory. So I have some like directory in the C. Just make sure in C, I call it C Vivado projects. Let me just do this here so that you get to see it. So I'm going to move this here and make it in the center of the screen. Okay, so now that you get to see that, so the steps, let me just actually go ahead and hide the circuit that we're going to do for a while. Okay, so now I hit that circuit here. So I have like the project, so you can call it whatever you want. So what we're going to do is I'm just going to call it first project. Okay, so that we can do that. And I'm storing all of these in here. It doesn't matter where you store it. What matters to me and to Vivado actually that there are no spaces whatsoever in here. So at the beginning when I first started, it gave me actually a lot of problems a few years back because my name has spaces in it. So I was putting it in under some folder under my name. It created some problems. Just make sure that there are no spaces whatsoever. I'm just storing it in this here. It's up to you where you store it. So I'm gonna do next, and in here it's gonna tell me what project type we have. In this course we're just gonna do RTL projects. We don't need any of the other ones, so we're gonna do RTL project, which stands for register transfer level. So we're gonna click next, and in here it tells me you want to add sources. You can definitely add sources, and sources are basically the modules or the circuits you're trying to implement. You can do it in this step, or you can do it later on inside the project. I'm just going to go on and do it inside the project. So we're going to click next, add a constraint. It's optional. Frankly speaking, if you want to implement it on the board, it's not optional. You'll have to have some sort of a constraint. But again, I'm just going to do it inside the project after I started. Like, you don't have to do it here. You can, but you don't have to. We're going to do that, and then in here you'll be faced with what type of FPGA chip that you have, and this is the part number with the packaging and whatnot. Like, you can take a look at your FPGA board and figure out which one it is. But frankly speaking, the support files or the support files we did from Digilent actually makes our life a little bit easier. You don't have to remember any of that. You can just go in here and do Digilent. You don't even have to do that. Like, all the boards that are installed in that directory we did are here. But if you want to restrict your options, you can just go to Digilent. You can say, hey, which board you have. So depending on which board you have, I do have the DDR. You probably will have the 100T. You click on that and it will figure out which package. It's this particular one, which is the XC7A100T. And this is the A100T. If you have the 100T, for example, if you have the 50T, you'll have the 50T in it. Anyway, I'll just do that, and it'll do this one in here. And we'll click next. And now my project is almost ready. So we do this here and we wait for a second. And my project is ready. So I have a blank project right now, and we can get started implementing it. So I'm gonna return that in here so that we could see it. This is what we're trying to implement. So, okay, how do we get started? Well, the first thing you need to do is actually you need to add a source. So I'm gonna go in here and I'm gonna say, I'm gonna click this little plus sign in here. So you click that plus sign in here and you will be faced with this particular one. It tells me, do you want to add a constraint or a source or a simulation source? Frankly speaking, throughout the course, we're gonna be adding all three of them. But for now, we're gonna do a design source because it's a new design. So we're going to do next, and then and then here you can actually do many of them. This is the same sub window that we faced a few minutes ago when we actually created a new project. So what you can add files if you already have them. You can add directories that have a bunch of files if you want them. But for now, we're just going to create file. You can do it from here or from here. So I'm just going to click create file. So the file in here, it's telling me, let me double check that you can see it. Okay, so in here I'm faced with, okay, so now you can see all of the window. I'm faced with what type of file it is. Is it Verilog, Verilog header, system Verilog, or VHDL? In this course, we're going to be writing Verilog code. That's it. And no other code we're going to be writing. We're not going to write any Verilog. Well, we can write Verilog header, but for now, we just need, for simplicity, we need to write some Verilog code. So you give it a file name. For example, I'm going to say buff. Well, it's not even a buffer. There's nothing there, but I'm just going to call it buffer or buff. Okay. I'm going to call it, this is the name of the file. It follows the same naming convention as any normal C file. So you shouldn't start with numbers. You can start with underscore, but anyway. So we're going to click OK, and now we have it. If you need more, you can just create more. Okay, so I'm going to click next, and in here I'll be faced with this particular module. It tells me define a module, and as it turns out, everything in Vivado, everything lives within a module. So this is here is what we call module. So whenever you create a new circuit or a new design or a new black box, we call it a module in Verilog. This is Verilog terminology. And it tells me you can define a module. You can tell me the port name. For example, in here, I can go ahead and tell it like I have an I and I have an O. I'm not going to do it this way. I'm just going to do it by hand. Or you can also say it's a bus, which I'm going to show you in a second. Anyway, I'm just going to click OK. And then you click OK again. And what you see is the new file being resources, or like the new sources in here will tell me, okay, you have a new design source in here and it's called buff. Okay, buff.v because it's Verilog. So I'm going to double click in here. Okay, and when you double click, you'll be faced with this particular option to write code for it. I'm just going to double click so that you get to see it. And that's pretty much it. Now we can get started. Now we're going to go ahead and fill that particular little box in here with something. And for simplicity, again, we're just going to do the simplest thing, which is connecting the input to the output. But before connecting and writing any code that lives within that box, what I usually like to do is I'll think about my design and I say, okay, what type of inputs do I have and what type of outputs do I have? And I just go ahead and write them. So what you need to do is you need to go in here and tell me, okay, well, I have an input. Okay, and that input is actually, I'm just going to call it, you can call it capital or small I. Or just remember that this is case sensitive, so it matters actually. And then you click comma. And then you can do, well, the O is an output, so I'm going to say output, and I'm just going to call it O, and that's pretty much it. I have an input and I have an output. And now in Verilog, all I have to do just now is connect them, so I'm going to say the O equals I. And frankly speaking, it's that you have to do an assign, and we're going to learn why you have to do this later, but it's actually part of the syntax for Verilog, and that's the simplest thing. If you had the simplest code that we can do, this is what we're doing right now. If you had other inputs, you can just add them here. For example, you can say I, B, C, or something like that. And you can also do this here. Well, you're going to do I, and then you're going to do another input. I mean, you're going to call it B. You can just do input, 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 or if they're the same size, you can put them right next to each other. Anyway, so we're going to do this in here, and now it's ready. So what we have is we have a code that is ready, and I can just go ahead and go to the RTL analysis. This is very useful. If you say open elaborate design, it will actually take a look at my code and try to figure out what am I trying to describe, because Verilog describes a circuit. We'll wait for a second. Everything in Vivado is quite on the slow side, so you're gonna have to be patient with it. So we're gonna wait for a sec. And now it's working. Okay, so and it did exactly what it did. It's just basically a wire in here. That's my input, that's my output, and there's a wire between them. That's exactly what my design looks like. So what do I have to go through now? Well, I should go and say generate bitstream, which will go through the synthesis and the implementation steps that we've discussed previously. But before I need to do this, well, I need to implement it on a board, on my FPGA board. Well, in this graph in here, I told you I'm gonna connect the input to a switch and the output to an LED. But how do I tell it which switch? I mean, my board has so many switches and so many LEDs. So you're gonna have to map it, or you're gonna have to constrain your design a little bit. So what you need to do is you need to go to resources in here. I'm just gonna close that elaborate design in here because I clicked on it. So I'm just gonna close it in here. I'm gonna say okay. All right. And then in here, I'm gonna go to resources in here, okay, and I'm gonna say, I'm gonna add, and now instead of resource or a source, actually, I'm just gonna add a constraint. Okay, so I'm gonna add a constraint in here, I'm gonna click next, and now I'm not gonna create a file for the constraint. In this course, we just have one constraint, and other courses or other designs, you might have more. For this course, we have this FPGA board. You don't have to create a file from scratch. I'm gonna provide you, or actually Digital provided us with some sort of a template, and I'm going to show you that. I usually say add file, and I usually have it like ready for in here. It's called Nexys 4 DDR master. Okay, so I click on that, and I usually say copy the constraint file, not like so that I don't modify the one in here. So this one here, I just use it. I keep it like in the root directory of all my projects, and I just copy it to my project, to the project I'm currently in, so that I don't modify the original. Okay, so I'm going to just copy it in here, and I'm just going to click finish. And then you will see that within your constraint, we have that added in here. Okay, so what can we do about it? We double click in here, and now we can say, okay, we have a constraint file, and the constraint file is actually quite long, but you're gonna see it's really easy to use. What we need to do is we need to say, okay, well, we have switches and LEDs, and this are tell me, well, these are the switches and these are the LEDs. All I have to do is just connect a switch to a specific LED. So let me show you. Before I move on, I just want to show you what's happening, what I want to do on the board. So on the board, we have so many switches in here. I believe we'll have from switch 0 all the way to switch 15. So we have 16 of them, and we also have like little tiny LEDs on top of it. So I have my board already connected in here through this USB cable. Okay, I'm just going to turn it on by clicking that in here. Okay, so it'll take some time. Usually it has some sort of a default program on it. It turns on like by itself, like, or loads. Yours might not have the same program initially, but anyway, that doesn't matter. What matters is the following. So it's doing all of this now, but I don't care about what it's doing. What I care about is the following. I have a switch as an input, so I'm gonna use this particular switch in here, which is switch 0, and I'm gonna connect it to this little LED. Okay, and that's what I want. Okay, so I'm going back to the code in here. So we're gonna go to the program window, okay? And in the code, what I have, well, why don't I just do that in here? Okay, so in the code, what I have is I have the following. In the code, it's telling me, well, I have switches, okay, and I have LEDs. Well, I wanted switch 0. This is switch 0, so I'm gonna uncomment this guy. Okay, and what I'm gonna say is inside what I really want it to be is I want it to be connected to my signal that I called I. That's what I called this particular signal in here. I called it I. If you called it something else, you just use that name in here, okay? The same goes with the LED. I'm just gonna go in here and I'm gonna uncomment this, and then in the LED, I'm just gonna say, well, I called it O. That's the output signal I have. And then you save that constraint file, and now we're ready. All you have to do now is just generate the bitstream, and then you wait a little bit. And after you wait and after you're done, it will take some time. It'll take a few minutes. I'll show you how we actually upload that program on the FPGA and just test it. When it's done, you'll be faced with this little sub window in here. It tells me open implemented design. If you click cancel by mistake, you can go in here and say open hardware. Frankly speaking, you don't want to implement the open implemented design. What you want is a hardware manager to load it to the to the FPGA. You can click OK, and again, it's the same as clicking this little open hardware manager in here. And I'm just going to allow access. It's probably because it's the first time it's using it, and no, I don't want to do this. Okay. And that's it. So now we have it. We're in the hardware manager, as you can see in here. I'm going to say open target, and I'm going to say auto connect. Of course, my FPGA board has to be on and connected through USB, and I'll connect through it. I'm just going to allow access. It's doing all of this because it's the first time I'm doing it with this particular fresh installation. It's the first time it's doing it. Afterwards, it shouldn't ask me these questions. Okay, so we're going to connect to the FPGA board. It'll take a couple of seconds. And now it's almost connected. Okay, so it got connected, and now it's telling me like, hey, you're connected to this particular digital and whatnot. Anyway, all you have to do is just go in this little tiny link. You say program device, and what you're trying to do actually is taking that buff.bit, which is a bit file. You can actually go in here and see it. It's actually like a file of physical file that you have, and we're just going to load it to the FPGA and test it. So we're going to click program in here, and then I'm taking a look at my FPGA board. Let me just show you what's happening. So on the FPGA board right now, you see it, nothing is happening, in fact speaking, because I need to switch that, flip that switch. So I flip that switch on or off, on or off. Whatever I do with the other ones, nothing happened because I didn't connect them. And my system literally take that switch and connect it to the LED and just does that. Okay. So let me just go quickly to the code again. And let me see if I can actually change that code a little bit. So can I change that code a little bit? For example, can I just do, instead of one switch, I'm gonna do a couple of switches. Yes, you can do another input, for example. We're gonna call this I0, and this is, for example, I1. And I'm gonna say a couple of outputs. And the last one, usually you don't have to put like a comma, but okay. So we're gonna do O0. Okay, this is actually confusing, like O0 and whatnot, but you get the idea. Like probably better names should have been used in here, especially with the I1, it looks like an IL. Okay, but we can do this here, and another output, an O1 for example. And now I'm gonna say, well, I want the I0 to be connected to, or the O0 should be connected to I0, and then I can do assign O1 to be equal to I1. And then you can go ahead, and when you actually go and say like, hey, generate the bit stream, you're gonna have to wait for the same amount of time, which is a long time. But you're gonna have an error in here, because what happens is you introduce a couple new signals. Let me just draw them on the diagram a little. So what's happening in here is I added another signal in here, and I added another signal in here. I called this I0, and this is O0, and then I called this I1, and this is O1. And I said like, okay, I needed to connect that, and that's basically what I did with the code. However, I didn't say that this particular one is connected to switch number 1, and this one is connected to any other switch. What you need to do is you need to make sure that you go to your constraint file one more time and just modify the constraint file to reflect that. Usually you get a lot of error messages if you have inputs not connected or not constrained in the constraint file, or the constraint file, for example, for some reason or another in here, you said like you uncommented this and uncommented this. You said you connected 3 switches, but your design doesn't have 3 switches. So if there's a little bit of a mismatch, you're gonna have some sort of an error. Usually it's like it has an IO error. Okay, so what I usually do again is I look at my design, regardless of what's inside it. I say what type of inputs do I have, what type of outputs do I have. I just write it in my module itself, and then I go ahead and I create my code. And of course I modify these inputs and outputs as necessary, but I usually start with them, and then I go to my it's called an XDC file, but that's how I usually call it. But it's a constraint file. That's its extension. Okay, it's a Xilinx something constraint. I forgot what the D stands for, but I can look it up. Okay, so you can do that. Anyway, so now I'm just gonna click that in here, and I'm gonna say, well, I have an I0, and in here it's actually I1. And frankly speaking, you don't have to use the second switch, right? Like the switch right next to the first one. You can actually use any switch you want. You can say, well, I want the other one on the other side, and you can just do this here, and I'm gonna connect the second switch to that one. Okay, you don't have to, like, you're free to use whichever switch you want. The same goes with the LEDs. You can do any of them, but what I'm going to do is just to show you, I'm going to just say this here, and I'm going to say the first one will be connected to the first switch, and then the second LED will be connected to this second switch. Well, but the second switch will be on the other side, and this one will be right next to it. Let me show you. So I'm going to do this here. I'm going to go through the generate bit stream, and I'm going to load it. It'll take some time, so I'm going to pause the video and just show you what's happening on the FPGA. All right, so I went ahead and programmed it now. So again, the switch 0 in here, it's actually controlling, switch 0 is controlling the first LED, and now the second switch is not doing anything, the third switch is not doing anything, but the last one in here, it's actually controlling the second LED, because that's how I did it. I just wanted that switch to be connected to my I1. You have the freedom to connect it to whichever switch you want in here, and it works exactly as it's supposed to. Well, let me just go back to the code and just see if there's a better way to actually do any of this. So obviously there's a better way. Like, let's assume that I want to use all of the switches and all the LEDs. I mean, this is ridiculous. I shouldn't be writing I0, I1 all the way to I15 and then all these outputs. Is there a better way? Yes, there is. Actually, you can treat these inputs and outputs as arrays. We're not going to call them arrays, we're just going to call them buses, or like a bunch of wires over there. So what you can do is you can say, well, let me just show you that. Okay, so what I did in here is the following. So we started with I and the output was O, okay? And then we said like output equals I, and I was one switch and O was one LED. Can I do it like a little bit bigger? And the answer is yes, and it's super simple. All you have to do is just do these square brackets, and then you say, well, I want to go from 15 all the way to 0, okay? So that's basically, I now is a 16-bit bus, okay, or a bunch of wires with 16 wires, and then you can do this in here, and it's like this is, oh, not 16 but 15 to 0, okay, and then the output, and I'm not changing the code at all. And what I really did is I connected I0 to O0, I1 to O1, and so forth. And now you have to go to your XADC or XDC file, and then you're going to do, well, this will be I and square bracket 0, and then this one here you're going to have to uncomment all of them. I'm just going to go ahead and do that so that I don't waste your time on the video. Okay, so what I went ahead and I commented all the switches and all of the LEDs, and I also connected the first switch to I0, the second switch to I1, the third switch to I2, and you can see it, we treat it like C arrays. It's not an array and it's not C code, and we're going to talk about it, but we can do this. The same goes with the switch with the LEDs in here. I went from O0 all the way to O15, and I went ahead and I said generate bitstream. Every single time you actually change something, whether it's a constraint file or the buffer or something, you're going to have to go and generate the bitstream all over again. You're going to have to wait. So the development process is a little bit slow because you're developing hardware. You're not just writing code. Okay, so I went ahead and I uploaded that code on the FPGA. So let's see what's happening. And frankly speaking, any switch you actually turn on, you'll see the LED associated with it will be turned on. You can do the same with the off, like any LEDs now. This is way more efficient than what we did before. So these buses will come in handy later on throughout the course as well.